but thanks for sticking with us. My name's Christian Hennessy. I'm the product manager at Oldcastle Infrastructure for our treatment product lines. Oldcastle is the leading industry leader of proprietary stormwater management solutions, including detention, retention, green infrastructure, and treatment. So I'm really excited to talk stormwater with these three gentlemen up here. We'll go ahead and let them introduce themselves, and we'll start with Don.
Thanks, Christian. Don McWilliams. I'm with the City of Bellevue. I'm one of the operations managers with Bellevue Utilities. I've been in stormwater since about 2008. Currently, I manage our maintenance division of stormwater as well as our regulatory compliance, which includes all of our programs like source control, illicit discharge, and our permit, the NPDES permit. Some of you may have heard of it. That's our permit that ecology gives us that allows us to discharge stormwater to our streams and lakes.
Great, thank you. Next, Mehring.
Good afternoon, everybody. Mehring Borchitz. I'm the Surface Water Program Manager for the City of Mukilteo. Moved up here across the country a year ago. Came from the Midwest. Just like Don here, I manage the city's NPDES program, making sure that the city is compliant with the permits from the Department of Ecology.
Thank you very much. And Andre.
Hello, everyone. My name is Andre Sklenar. I'm an environmental program manager with the Port of Seattle. I joined the port earlier this year in their maritime stormwater utility, which is about a 20-person team which oversees all maintenance, operation, improvements of the stormwater utility for our tenants. My background's in civil engineering and urban planning, and prior to working at the port, I primarily worked as a civil consultant on green infrastructure design, hydrology, hydraulics, modeling, site development. Thank you.
All right, very good. Well, thanks for that, you guys. We're going to dive right into it since we don't have a lot of time. So pardon me if I'm moving a little quickly, but I want to make sure we get through all the questions and have time if we want to expand on any of them. So to begin, green infrastructure technologies have been widely deployed as a means of treating and controlling stormwater runoff throughout the Pacific Northwest. Now that we are able to start seeing the impact of these types of BMPs, can you speak to the effectiveness of these systems and how they are being applied in practice? And we'll start with you, Mary.
So the city of Mukilteo has quite a few green infrastructure, low impact development sites. It's in our code. It's a preferred BMP to be implemented. We have been part of a study by the SAM group that is looking at the functionality of bioretention cells for the last 15 years. They came out this year to look at some of ours. So in my experience, from what I've seen over the last 22 years of working in stormwater here in the United States, is those green infrastructure BMPs are functioning no better or worse than traditional systems, in my opinion. They only function as well as they are taken care of, same as the traditional systems. And also, the challenge with the green infrastructure is just that it takes a little bit more effort and a little bit more knowledge. Some of the previous panelists were talking about education and how important it is to have the folks that work on the utility be educated, knowing what they're looking at and knowing knowing where to find the information if they don't have the information on how to do the inspections and the maintenance. So that's my 2 cents on that.
And I'll go next. So the Port of Seattle Maritime is a bit of a unique landowner in the way that we're essentially between kind of the interface between land and water. So across our 40 properties, we kind of have specific requirements which dictate what type of BMPs we install. It's mostly water quality. We don't have combined sewer systems. We don't need to do flow control. It's all direct discharge into local water bodies. And with the utility being newer, it was formed in 2016. I think at first we were looking at infrastructure improvements and understanding what our assets are. And really quickly we started adding green stormwater infrastructure to it and trying to kind of continually increase the amount of water that we treat from our properties each year. And even though we're relatively small, we still discharge in a typical Seattle rainfall year 1 billion gallons of stormwater to the sound. So in terms of what GSI elements we're doing and looking to do, I think within our current toolkit, we have a lot of like non-infiltrating biome retention, infiltrating bioretention. We have our first green roof. There's a project that just went out to bid at Fisherman's Terminal to build Seattle's fourth living building, the Maritime Innovation Center. So there's definitely a lot of excitement about GSI and a variety of toolkits which are being built by either the utility or redevelopment on maritime port properties. At the same time, kind of given our history and location, we do run into certain limitations which are kind of deal breakers in a way. Just about all of our property is on fill, and a lot of the older properties has significant contamination. So doing, infiltrating bioretention and contamination is frowned upon. And second, a lot of our properties are, cargo terminals. So when we're talking about the several million cargo containers that come through the Port of Seattle each year, every single square inch matters for the workers there. So it's all impervious hard surface, and instead of using kind of GSI in those elements, we definitely find that like proprietary water treatment systems work better. I think the final step in kind of increasing GSI is just making sure we have the maintenance staff to take that on. So I think that's our long-term plan to essentially do a lot of our big asset rehabilitation now and increase GSI and train our workers to transition on maintaining those systems.
Yeah, absolutely. On the industrial side, you're much more held to specific standards, effluent concentrations, and have a very interesting mix of pollutants to contend with. So that makes a lot of sense. And Don, how about you?
So in Bellevue, our main GSI components are bioretention swales, bioretention ponds, bioretention planters that you'll see along our roadsides when we construct new roads in Bellevue. We have some as old as 20 years old. They still function, they still work fine. All benchtop testing we've seen of this product is very positive. It works very well at removing many, many chemicals. Ours seem to be working. We maintain them to a very high standard, but we don't do water quality testing on them per se to find out if these chemicals are actually getting caught up in the material or if they're leaching through. We do know that when they're first installed, there is some leaching that occurs from the natural minerals in the bioretention mix, but that goes away after a little bit. So I believe there's some studies coming up out of that SAM program that Marion mentioned that is going to look into this. So that'll be interesting to see what we get.
Yeah, absolutely. Definitely, I think there's an interesting conversation and progression around the quality, beyond just validating it through programs like TAPE. So moving on to that, just kind of an extension of that question. What limitations have been identified with the current designs, proprietary and non-proprietary, and where do you foresee green infrastructure as well as stormwater infrastructure going in the future? Don, we'll start with you.
I think there's a lot of opportunity to put GSI out there. You just have to be creative. More so on the private side than on the public side. The public has a limited right-of-way to work in, limited space to build our roadways in. So above ground GSI is difficult to incorporate, to get enough sizing to put it in correctly. I think on the private side, there's a lot of room. There was a picture up here earlier of some rooftops, building rooftops. I think there's a lot of room there to expand. There's a lot of room on some of these larger buildings to put GSI down and around the bases of the buildings that you can really treat this stuff before it gets into the public system and into our streams.
Marion or Andre?
So I think that the thing with the green infrastructure, low impact development is that it's not something that stands on its own. It's not a basin or a vault. I think when you are thinking about the green infrastructure and how to use it in stormwater, is that you integrate it with the rest of your land use planning. So like they said earlier here, there's, I think, only 2 land use planner professionals in the audience, which, I feel like those folks are integral with utilities, especially stormwater utilities. So I think that the really good place for green infrastructure is in implementing it in the rest of the land use landscape in the community. For instance, I have a couple of projects that I'm hopefully getting some grant. We'll be doing some grant funding for along roadsides, and in those areas, it's not just for capturing the stormwater in the open swales or ditches that we have now. But it's also for traffic calming. So you don't only use it for stormwater management, but you also use it in your transportation management and the way you manage your traffic through your neighborhoods. In our draft permit, trees are becoming, some a BMP that the Department of Ecology really wants communities to start using. From the federal level, we hear all the time about increasing the canopy for climate resiliency. So again, we can use the green infrastructure tools that's out there and incorporate them into your climate change resiliency, climate change action plans, and transportation, as I said earlier. So I think the win for green infrastructure is really thinking of how you can incorporate it with some other goals that you want to achieve in your land use planning.
Yeah, absolutely. And Andre, I have kind of a spin-off for you specifically, since obviously you noted green infrastructure is not as pertinent to the ports. So based on your experience with the industrial permits and the applied technologies, are there any emerging technologies that you're excited about or that the port has implemented that they found to be particularly effective?
Yeah, kind of just background on that to explain the permitting for that is that the Port Stormwater Utility operates under Phase 1 general permit, but a lot of our tenants have their own industrial permit, and this is a way to kind of separate their operations from our operations and just make sure that both parties have full control over meeting, ecology requirements. Some systems that we have been incorporating on the industrial side, which are kind of emerging, we do have these like oyster barrels and oyster shells. We take Washington oyster shells from Taylor shellfish, grind them up, and put them in trench drains or kind of plastic barrels, and they've been found to reduce, copper and zinc loading into water bodies. They're not tape approved, but they're relatively inexpensive to implement and maintain, and they could be reused several times. So that's been a good one for us. In terms of other systems coming our way, it seems like we'll have this proprietary treatment system. The race is, the smaller the filter you can make, the higher flow rate it can handle, the more pollutants it can remove, the more kind of appealing you are to customers. So it's definitely been interesting to see what type of treatment systems we have on our industrial properties. They vary by manufacturer, and be in touch with our maintenance teams, which ones they kind of maybe lean towards, which ones clog more frequently or less frequently, and just stay on top of, what's coming our way, especially as new chemicals are being identified which need to be treated for.
It's like we talked about this beforehand, because that's a very good segue into my next question here. So concerted effort has been made to validate the performance of stormwater technologies, as you noted, through programs like NJCAT and Washington Tape. However, the longevity and maintenance of such technologies has been an ancillary consideration. From your perspective, how important is the maintainability of filtration and green infrastructure technologies, and what are key elements of design that improve maintenance activities? Start with you, Mary.
As a city, with the code, all infrastructure that gets implemented from the private development side and from our own side has to follow the standards. We use the Department of Ecology's manual and permit, so we base our minimum requirements on the state's minimum requirements. There are communities out there that, I'm not sure about Washington, I'm too new here, so I don't want to speak out of turn, that can have higher standards, but City of Mukilteo just do the minimum because we have adopted the Department of Ecology's manual and permit.
So maintenance at GSIs can be all over the board. They can be rather difficult and cumbersome for the maintenance crews. I hear it from my staff all the time. So my staff is very good at cleaning catch basins, pipes, conventional vaults, tanks, ponds, that kind of stuff. Anything that requires a vector, an excavator, and just some hard labor. You introduce bioretention swales and plants to them, now they have to become landscapers, and that's not their forte. And then you also have to teach them how to measure down into that soil to make sure it's functioning correctly, how the percolation works, how to test that, how to check that when they do their inspections. They have 20 some odd thousand structures they have to inspect annually, and for them to take the time to inspect GSI, I often hear is just too cumbersome for them. So it's requiring additional specialized skills. And now we're seeing underground GSI, modular wetlands, things like this go into place, where you have to lift vault lids out of place to be able to look in there and test it. And manufacturers are using proprietary lids for the manhole covers. So it's not your standard round 36-inch that we're used to picking up. It's now bigger or smaller, and it's a different size. So there's some specialization that's required when you get into GSI with your maintenance crews, and some patience that has to be taken. And you have to understand as a manager of those maintenance crews that it's just going to take longer until they get a rhythm going with it. It's the right thing to do. I'm all for it, but it is going to take more resources to implement this technology.
Yeah, being new to the port utility, I've definitely learned that like operation maintenance and staffing needs and utility finances are very intertwined. For us, we have like a 19 or 20 person group, and of that, 3/4 of them are in operation maintenance. And when you look at their list of work orders that are standing for regulatory compliance and cleaning and repairs, it's extremely extensive, and a lot of our infrastructure is older, so emergencies come up, essentially on a daily basis. If there's a sinkhole at a terminal, it needs to be fixed as quickly as possible. So I think adding this GSI maintenance to it, there's definitely a lot of discussion about, what staffing needs we need and what specialties, and also making sure that, we serve our tenants, so making sure that the rates we charge, that we kind of carve out enough money for operation and maintenance and capital projects and balance it all out. So I think we are hoping, as I kind of alluded to earlier, as if we do have our significant repairs in the next couple of years, that we'll be able to carve out more staff time to training on, operation and maintenance of GSI elements.
All right. Thank you very much. And again, kind of continuing on that same maintenance conversation, how do you foresee maintenance impacting product selection and agency approvals in the future? And how do you envision that being enforced in the future? Don.
So my maintenance crew, I have a couple of representatives that sit on our developer review team just for this. We're looking very carefully at GSI designs that are going to be owned by the city into the future. And we're asking questions like, can we replace that abstract manhole cover that you have there with a vault lid that opens, a bifold vault lid, so we can get in there easier? Little things like that. And then sizing it correctly. A lot of people are oversizing GSI, trying to use it as detention, and it can be used for that, but that's not where it prevails. It prevails at first flush treatment. It's designed to capture those pollutants that come off in the first 10, 15 minutes of your rain event, and then go ahead and let it go to overflow and into traditional stormwater detention means after that, because that water's 90% cleaner than it was 5 minutes ago. So I'll leave it at that.
Okay.
So I think all of this stuff is an evolving industry. So for instance, with the city, when I started a year ago, we were talking through all the vaults we had. But in the last 25 years, nobody's been inside a vault. So, it's those things that you realize as a manager that you need to do. So starting next year a program where every 5 years we're going to go through and have a specialist structural engineering firm actually go inside the vaults to make sure that this vaults are structural inside. Because when you do a vault inspection, mainly you look at your flow control structure and you stick a rod down to see what your sediment depths are. Very in the city of Mukilteo, we have no data of the structural integrity of inside the vault. We don't know if there's cracks in the corners or at the bottom or at the top of the concrete chambers. So just small things like that, realizing those things, thinking through those things, I think is very important in involving your inspection program. And the one thing I would say about construction is just, I'm always under the assumption that the city will take over that structure. So it might be a private structure today, but you do not know who's going to own that structure in 30 years or 40 years from now. It's beyond our thinking as the person managing the program today. So always think about far out about what's even going to happen after you leave.
Yeah, I think that's a very good point. We think so often about just the immediate, few years ahead and how it's going to work in that time frame, but 10, 20 years beyond, how are we actually maintaining these and how are they working?
Yeah, and if we talk about infrastructure and the longevity or the design life of the infrastructure, I think everybody in this room knows that they have a large percentage of their infrastructure that's way beyond design life, and they still don't have a plan for when that will be redeveloped, reinstalled, rebuilt. So when you review things, when people put things in, you look at it from the design life and you assume that's going to get replaced in 35, 50 years maybe. But as we have learned now, many years later, that's actually not the way it works in the real world.
Yeah, very true. We only have a few more minutes, so I want to make sure we get to this last question, which is for everybody up here. I think, it's definitely a hot topic right now, but as new pollutants of concern continue to emerge, such as PPDQ and PFOS and PFAS, how do you envision cities retrofitting existing technologies to support the treatment of these pollutants of concern?
I'll start. Has everybody heard of 6PPD, 6PPDQ? Raise your hands. Okay, a good portion of you. For those of you who haven't, 6PPD is a tire preservative. It's been in the tires for a long, long time. It was recently found that when it dissolves off your tires and turns into little tiny particles on the road and gets into our waterways, it turns into 6PPDQ or quinone. And don't ask me what PPD means. It's a word about this long. Anyway, it kills fish. It kills our coho susceptibly. And it's called urban runoff mortality syndrome. We've seen it for years and years and years, and we just recently found out what the cause is, and it's this 6PPDQ. So how do we retrofit for this? Ecology is putting a new clause in the Phase 2 permits that's going to require us to start retrofitting. It's been in the Phase 1 permits for some time. Retrofitting an existing stormwater system is very difficult. You don't have a lot of room. It's really hard to dig up a roadway. You got other utilities in the way. So pulling out a vault, changing it out with a new vault is extremely difficult. Your best bang for your buck is to go after your above ground areas, your ponds, your ditches, those kind of things. Or if you have an open roadside, construct a new bioretention swale and route things through there. Underground retrofits can be done. And we're going to try some in Bellevue, but we're going to do them one at a time and see how they go, because we know they're going to be very expensive.
Yeah, I was at the Ballard Locks about a month ago with my 3-year-old, witnessing the record salmon runs, and a boat came by covered with maybe a dozen cracked tires, and I started shaking my head, and he kind of looked at me why, and I figured explaining to him why 6PPD leaching into Salmon Bay is an issue was maybe over his head. But it is something that's definitely on the port's radar. At the airport, they're dealing a lot with PFAS. For us, we're tracking 6PPD. I think for us, it's almost, we kind of defer to the experts in this on guidance. Even this morning when I was trying to read up on 6PPD, it seems like there's a lot of known unknowns. So I'm hoping that a lot of those stopgaps get filled in the coming years, and the utility can start incorporating more recommendations.
Mary?
Yeah, I think that as a stormwater manager, I'm going to lean on the professionals to come up with advice on how to deal with it. From the regulatory perspective, the city, as a city manager, we have to implement and plan implementing whatever the permit requires. Like most regulatory agencies, they at least give you time, resources to do so. So I think we'll be fine. We've been here before, and I think we'll get through it. But I also don't think that it's one agency, one group fix the bill. All of these problems are industry-wide. So there are hundreds of thousands of miles just in Washington. So I'm not sure how we're going to, build enough bioretention cells or soil-based stormwater best management practices to deal with that. So I think we'll have to work with the industry and other partners to come up with a solution for 6 ppdq. PFAS, the problem with that is, in the 50s and the 40s, they designed it to last forever. So, and what is forever? So we'll have to work we're going to work with our fire department on the next permit to come up with a PFAS management plan. And the fire departments, it's my understanding that they've actually moved quite far along with managing PFAS, because that's in everything they wear and in everything they use. So hopefully we'll combine knowledge and combine resources and come up with a way to manage PFAS in the stormwater systems as well.
Thank you all.